probability. Don't worry, I will get there eventually. All the same probability of things. What, ladies and gentlemen, is probability? Somebody want to shoot me at what probability is? Caleb Fisher, what is probability?
Chance of something happening?
No, probability and chance are actually two different things, but they mean the same thing. How about that? Can I say that? Two different things, but they mean the same thing? What is, if you were describing me probability, what is it? All right, I'll tell you. It is the likeliness that something is going to happen. The likeliness of something happening. And probability, children, probability is expressed or shown as a fraction. Write this down. It is a fraction. Obviously not dark enough for you, but that will be as a fraction. And here's how that fraction works. Boys and girls. Here is how it works. Let's say I've got a line here where this is 0 and this is 1. And I cut it into some pieces here. Let's just cut it in half here. If something has a 0 probability of happening, which if you want to write it in fraction form, be 0, 0, it basically is impossible. An example of that would be the probability of you not getting homework today. Impossible. I couldn't probably say that. I could collapse right now and you wouldn't get some. But let's just say the probability of today not being Thursday, that would be impossible, right? Yes, Mr. Hahn?
Yes, Mr. Hahn.
Where a probability of 1 is absolutely positively certain. Something that is can't be false. For example, the probability that today is Wednesday. That is actually certain. That's a 1. And then you've got all the stuff in between, which really we deal with on a regular basis. If something has a probability of 1/2, that means it is as likely as not to happen. That's a probability of 1/2. Anybody give me something that's usually as likely as not? What are some things that are 50-50 as we call them? Although that's not probability either. Lauren!
Rain.
Wait, is that every day is 50-50? Wait, you think it's going to rain every day? I don't know if we can do that. What are some things in our world that it's 50-50? I would say the probability that you're going to be born a boy or a girl. Probability if somebody's having a baby, it's 1/2. You know, I think that, well, I don't know if we did the statistics of all the world, if there's more boys or girls, but that would typically be 1/2. Madison?
Somebody dying.
No. Wait.
Please.
So you're saying tomorrow the probability of any one of us dying is 1/2? It's as likely as not that tomorrow we're all going to die. By the way, the probability of dying is right here. Well, I guess I can't say that because if Jesus came back, we wouldn't necessarily die. So the probability that everybody else before us died. Yeah. Come on, somebody give me a 50-50. When it's a fair, a spinner. You know, if you have a spinner and cut it in half and you have part A and part B, that would be, it's as likely as not to get A or B. But usually we flip a coin. We go to a football game, who gets to be home team or who gets to choose whatever, they flip a coin because that is about as likely as not for you to get that sort of thing. I'm not going to ask anymore because I don't think we have any concept there. And then if something is, if something is less than 0.5%, if it was a fourth or, whatever, 3/4. Wait, no, that's higher than 1/2. Or whatever, what? Give me, huh? a third, or an eighth, or whatever, that is probably not likely to happen. Whereas on the other side, if it's greater than 1/2, it's probably likely to happen. And remember, I mean, this is probability. These are not sure things. Even if something is probability of whatever, 15/16 or something, there is a small little window that it may not take place or whatever. But just know that you have those things. Now, here, let's do an example problem. So here, well, they give us this spinner. I'm going to do this one. Here's a little spinner they have here. You have to be a little careful with this. A, B, and C. By the way, when we show probability, we usually use the capital P, and then what we want to happen, we put in parentheses. So if I asked you what's the probability of spinning a bee, this is kind of how I would show it. The probability of spinning a bee. That's how we mathematically show that without having to write out all those words. And probability works like this. On the bottom of the fraction is the total equal outcomes. And on the top of the fraction is how many are the ones you want. So you make a fraction out of those two things and you can't go wrong. In this case here, you have to be a little careful here because notice I said how many total equal outcomes. And if you look at this, you might say there's only 3 outcomes, but there are. But what do you notice? The letter C is twice as big as the other. So when you do probability, you got to make sure they're equal. So you'd have to cut this in half and call these both C's because they have to be equal. Otherwise, it doesn't make, you know. If I had a spinner and I said, okay, Zach, you know, I've got, here is the letter A and here's the letter B, and if I'm spinning it and I say, well, Zach, is it, you know, is that fair that you're going to get an A all the time? No, even though there's only 2 possibilities, you've got to cut it into those equal parts. So here, the probability of me spinning that, there are 4 different choices. Well, not different, but there's 4 equal pieces. How many of them are B's? Just 1. The probability of me spinning a B is 1 out of 4. The probability of me spinning a C, well, there's 2 pieces that are equally that big, would be 2 out of 4, and you do reduce those, so your probability is 1/2. The probability is 1/2. Does that make any sense to anybody? Now, along with probability, a lot of times the book will ask you for sample spaces. What is a sample space? Have we talked about this before? A sample space is the possible outcomes. For example, sample space for the spinner. For the spinner, you can get an A. You can get a B, you can get a C. Let me make sure they don't give us 2 C's or not C's. Yeah, maybe not. I guess you just get an A or a B or a C. I suppose we should put 2 C's down there. Now let's check this out. What if I ask you to flip a coin 3 times? What would be the sample space for flipping a coin 3 times? Well, what are the different combinations when you flip a coin? I'll give you the 2 easy ones. You could get a head, and then a head, and then a head. Or you could get a tail, tail, tail. What are all the other combinations for that? What would be another one? Madison, you could have a what?
Head, tail.
You could have a head, tail. Or you could have a, Lauren?
Head, tail, tail.
A head, tail, tail. Or you could have a, you got more, you got lots more actually. Autumn?
Head, tail, head.
You could have a head, tail, head. Or you could have a, Layton?
Tail, head, head.
Tail, head, tail. Or you could have a, or
Tail, head, head.
tail, head, head. Or you could have a, now, you could go on forever making this, and how do you know though that you've got them all? Anybody? Caleb's thinking, how would I know if I have them all? You really don't, for sure, unless you organize your thoughts, ladies and gentlemen. And this is how this would probably be the best way to do this. Organize is make yourself, well, I don't know, it's just a tree kind of there. I don't know what we call this in space. On the first flip, what are your choices? If you flip a coin just once, your choices are what? Either a head or a tail, correct? Well, you make that your first layer, and then on the second flip, off of each one of those, I could get either a head or a tail for my second flip. And then on my third flip, off of each one of those little branches, I could get a head or a tail. And then if you kind of follow the little tree limbs down, you would get all of your combinations. In other words, if I go head, head, tail, head, 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 I could go head, head, tail. Anybody see that? I can go head, tail, head. I can go head, tail, tail. That's all. That are all the combinations when I flip a head first I could get. Then over here are all the ones I can get when I have tails. Tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. So we did get them all over here, I think. No, we missed one somewhere. Which one did we miss? There should be one more. You have 8 different combinations there that you could have done. Since you can't see those. 8 different combinations. Now, with that being said, if I asked you what would be the probability, if we did this little thing, what would be the probability of getting all 3 tails? When you flip a coin 3 times, what is your probability that you get all 3 tails back to back to back? Again, remember the rules of probability. How many different outcomes did we come up with? How many were there?
8.
8. And how many of them were tail, tail, tail? Zach?
1.
Just 1. Your probability is 1 out of 8 times when you flip a coin 3 times, you should get all tails back to back to back. Now, does that mean it's going to happen 1 out of 8 times? No, but that's the probability. Now, that leads us to, oh wait, does it talk about chance? Maybe we don't talk about chance. Do we talk about, yes, we do. That leads somebody to ask, but what about chance? Take out a blank piece and write chance, because chance is different than probability, but it is the same. And it'll be fast. Chance is really the same as probability, but anybody know what it is? When you listen to the weather forecast, they do give you the chance of rain. They don't give you the probability of rain. And what do you notice they say? What is the chance of rain today? If you had to guess. Yeah, it is some percent. Chance is the same as probability, but in percent form. So if it is a 30% chance of rain, the Is it likely to rain or not likely to rain? Chase?
Not likely.
Right, because that falls in the below 50% range. Does that mean it'll rain? Probably, just because usually when they say it's 30% chance, it does rain. I don't know what that says. What does that say? Like, not like, with T? Not like. Everybody got that? That should be relatively easy then. And then last but not least, with this, they also talk about a complement. When they talk about complements, when they talk about probability or chance, a complement is the opposite of the event. The opposite of the event. Which means, if I were talking about a 30% chance of rain, the complement would be the percent that it won't rain. Alright? Or what is the chance of me, what would be the chance of me randomly picking a boy from 6th grade? Chance of picking a boy from 6th grade. Wait, anybody absent today?
Brian.
So there's like 20 of you, right?
No, it's Brian.
Oh.
Sarah, Sophia. That's it. That's
I
it.
see Joseph. No, get all. Alright, so there's 18 of you.
Yeah.
How many of you are boys right now, John?
7.
Alright, so the probability, the chance, we'd have to change 7 18s into a percent. Anybody want to do that for me? So you know what that is? Right off the top of your head? Taking a shot. James, what do you think it is? Give me just an estimation.
40%?
I think you're probably pretty close. That's what I was going to say. There's about 40% chance of picking a boy. Well, what would be the complement to that? What is the probability or the chance of picking a girl? Which would be, wait,
60%.
60%. And the book will ask you this, so make sure you catch on to this. If you take an event added to its complement will give you what? So like we said, we did 40% for boy and 60% for girl. You add those together, you're going to get, Zach,
100.
yeah, 1 actually, which is 100%, which is the right. I'm just saying that's what the book, Zach, I only say that because that's what the book will ask you. Yes, it is 100% and it's the fraction 1 over 1, but they will say, they will use 1. A complement or an event and its complement is certain to happen. It is 100% or whatever over whatever percent.